You know, when you see a shooting star, you might be thinking of something else entirely. But today, we're going to talk about the real rock stars of our solar system, these incredible, mysterious things we call comets. I mean, for thousands of years, people have looked up at the night sky and seen them. These amazing, glowing things just blazing across the darkness. The ancients actually called them long-haired stars, which is pretty cool, right? But for pretty much all of history, the big question was just, what are those things? Well, before we had all our modern gadgets, telescopes, space probes, the answer people came up with was, well, it wasn't great. Yeah, for most of history, seeing a comet was basically a sign of doom. People thought it meant a disaster was coming, or a war, or maybe even that a king was about to die. But thankfully, science came along and gave us a way more interesting and way less scary explanation. So to really get what a comet is all about, we've got to look under the hood, so to speak. Let's crack this cosmic code and really break down the anatomy of a comet. We're going to find out what's really going on inside these amazing travelers of the cosmos. Okay, so here's the basic breakdown. A comet is essentially a small, icy body in our solar system. The best way to picture it, just think of a giant cosmic snowball. It's made of frozen gases, rock, and dust. And the really wild part? These things are leftovers from when our solar system was first forming, like 4.6 billion years ago. They're ancient. So let's zoom in. Right at the very heart of every single comet, you've got what's called the nucleus. That's the solid core, this packed together ball of ice and rock. And here's the kicker. Even though comets put on this huge, spectacular show in the sky, the nucleus itself is actually pretty tiny. We're talking just a few kilometers wide, about the size of a small town. Isn't that crazy? And that idea leads us straight to the most famous description ever. Back in the 1950s, an astronomer named Fred Whipple gave them a nickname that just stuck: dirty snowballs. And honestly, it's perfect, right? It's such a great way to picture them. Just a frozen core, all mixed up with rock dust and all sorts of other cosmic stuff. Okay, now this is where the real show begins. As a comet gets closer to the sun on its long journey, the heat starts to do something amazing. See, the ice on the nucleus doesn't melt like an ice cube. Nope, it skips the liquid phase and turns directly into a gas. That process is called sublimation, and all that gas spewing out creates this giant, fuzzy, glowing atmosphere around the nucleus, which we call the coma. And when I say giant, I am not kidding. A comet's coma can get unbelievably big. Get ready for this. It can swell up to be 15 times the diameter of our entire planet. Think about that. You've got this massive, glowing cloud all surrounding a tiny little core that's only the size of a town. It's just mind-boggling. All right, and trailing behind that massive coma are the most famous parts, right? The tails. But here's something really cool you might not know. A comet doesn't have one tail. It usually has two totally different ones, and they're formed by two different forces from the sun. So first you've got the dust tail. This one's made of, you guessed it, dust particles. They get gently pushed by the pressure of sunlight itself, which is why it looks kind of curved and yellowish white. But then you have the ion tail. This one is made of super lightweight gas that's been ionized, and it gets absolutely blasted straight back by the solar wind. That's why it glows blue and always points directly away from the sun, no matter which way the comet's going. So that dirty snowball idea is fantastic. It's a great starting point, but, science moves on. And recent research has given us an even better and maybe even tastier analogy. Some scientists now say comets are like deep-fried ice cream. I love that. It gives us a much more complete picture. You've got a hard, dense, icy crust on the outside that's been fried by the sun, and it's protecting a colder, fluffier, less dense inside. How cool is that? All right, so we've zoomed in and seen what a comet is made of, but that's really only half the story, isn't it? To really get the picture, we have to zoom way back out. We have to ask the big question: where do these things even come from? So let's follow a comet on its grand tour of the solar system. It turns out comets basically come from two main neighborhoods, and that gives us two different types. First, you've got your short period comets. Think of Halley's Comet. These guys come from the Kuiper Belt, which is this big, icy region out past Neptune. Their trips around the sun are relatively quick, less than 200 years. But then, you have the long period comets. These ones are coming from the Oort cloud, this enormous spherical cloud of icy bodies at the very, very edge of our solar system. And their journeys? They can take thousands or even millions of years. So if you think about it, a comet's whole life is this really dramatic cycle. For most of its existence, it's just out there in the deep freeze, totally dormant. But then gravity gives it a little nudge and it starts its long journey toward the sun. That's when it activates. It heats up. It forms that beautiful coma and those two tails. It's at its absolute brightest and most spectacular when it reaches its closest point to the sun, something we call perihelion. And after that, it starts its long, slow retreat back into the freezing darkness, where it all quiets down again. Until next time.
You know, this is all incredibly cool stuff. But you might be wondering, okay, but why does it matter? Why do we spend so much time and money sending missions to chase after these icy rocks? Well, the answer is huge. It's because they're so much more than just dirty snowballs. They're like echoes from the very beginning of everything.
Here's the key idea. Comets are cosmic time capsules. Seriously, because they've spent almost their entire existence locked in a deep freeze, way out in the cold, they are perfectly preserved. They're pristine leftovers from the birth of our solar system. So when we study a comet, it's like we're getting to analyze a sample of the original stuff that built the sun, the earth, and everything else. And get this, we have studied them, like right up close. It's amazing stuff. NASA had a mission called Stardust that literally flew through a comet's coma, grabbed some dust particles, and brought them all the way back to Earth for us to study. And even crazier, the European Space Agency's Rosetta mission actually orbited a comet for 2 years, and then it landed a little probe right on its surface. We landed on a comet. It's just incredible. So what did all that effort get us? Well, these missions found something mind-blowing. They confirmed that comets carry organic compounds, the chemical building blocks of life, and that leads to one of the biggest, most profound questions in all of science. Is it possible that comets, by crashing into a very young Earth billions of years ago, actually delivered the water and the very ingredients that kicked off life on our planet? Wow. Okay, we have covered a lot of ground, right? We've gone from simple, dirty snowballs all the way to the origin of life itself. So before we wrap this up, let's do a super quick summary. Let's lock in the 5 key things you absolutely need to remember about comets. All right, here's your final briefing. Ready? First, the core. Remember, it's that dirty snowball of ice, rock, and dust. Second, the glow. That comes from the sun's heat, causing it to spew out gas and dust, forming that huge coma. Third, the tails. Don't forget there are 2 of them, the curved dust tail and the straight ion tail. Fourth, their origin. They come on these epic journeys from way out in the Kuiper Belt or the super distant Oort cloud. And finally, number 5, the clues. These things are ancient relics that might just hold the secrets to how life got started. Pretty important stuff. So it's pretty clear there's so much more than just bad omens in the sky, right? They're these incredible time capsules from the dawn of our solar system, and they've already unlocked some amazing secrets about our past, and maybe even our own origins. It just leaves you with one big, exciting question. As we keep exploring them, what else are they going to teach us?